Hello and welcome to Operations with Complex Numbers. Operations is really just a fancy word for add, subtract, multiply, divide. So that's all we're going to be doing here is add, subtract, multiply, and divide complex numbers. Now what I'd like you to do to start is to pause the video as soon as I move out of the way and write down all of this, and then we can fill in the blanks together. Ready? Pause. Write it all down. Pause, pause, pause. And start. Here we go. A complex number. We've talked about it a little bit. It doesn't mean that it's extra tricky. It means just that it's a number in the form a plus bi, where a and b are both real numbers, and I is the square root of -1. So something in this form is called standard form for complex numbers. The number a is the real part, because that's just a normal number. There's no imaginary pieces. And the bi is the imaginary part. So we've got a real part here, and an imaginary part here. And together, the real and the imaginary together make a complex number. That's why they're called complex. Okay? Solutions should be written in this form, a plus bi. Notice the real is coming first, the imaginary is coming second. So we're going to look at how we can possibly add and subtract numbers that have real parts and have imaginary parts. So again, pause and just get this example down and start. Okay, we've got -3 plus 6i minus -5 minus 3i, all in parentheses, minus 8i. We know when we see a negative that really is a -1, so let's deal with this first. We have -3 plus 6i plus 5 plus 3i minus 8i. Now, real, imaginary, imaginary. We put the imaginary parts together, put the real parts together. Which one comes first? The a comes first. We want it to look like this, so we'll put the real parts together first. -3 plus 5 is 2, and 6 plus 3 is 9. 9 minus 8 is 1, so really we just have 2 plus I. We would say that A is 2 and B is 1, even though we're not writing it. So it's A plus BI, 2 plus I. Okay, in this problem, square root of 64, wait, I know that is 8. There's no negative. I can deal with a positive radical. That's just going to be 8. But this one I can't do anything with as long as it's negative. So I need to change this. Now it's positive. I know how to deal with a positive square root of 16. That is 4. And this is I. So we have 8 plus 4i. A plus bi, real, imaginary. This is standard form. Okay, this is how you add and subtract. Put together the things that are real, put together the things that are imaginary. Multiplying and dividing with one term. Go ahead and pause and get these examples down. And start. Okay, we can't do anything with these square roots as long as they're imaginary. This does not exist. Square root of -50, we cannot do anything with that. Please do not try to divide this and say -50 divided by -10 is 5. That is completely wrong. But we know that we can split this into -1 and +50. And we can take this into -1 and +10. And we can deal with positive square roots. So this is I over I. And this is square root of 50. And this is square root of 10. We can deal with these. I divided by I, anything divided by itself is just 1, so they cancel. And positive square root of 50 divided by square root of 10, these are both positive. So now we can actually deal with this, and that is equal to square root of 5. We need to be careful, please. Don't, even though it looks like it's correct, it looks like it's right, don't fall into this trap. Make sure that we're writing out what it is. Because in a problem like this, it's completely different. Okay? Because here, we would divide, and if you do the same kind of thing, you would think, oh, that's just square root of -3. No, it's not. This doesn't exist. We need to change this. 21 times square root of -1 times square root of 6. Okay? Now some of these things exist. I can deal with 21 divided by 7. Those are plain numbers. That's just 3. I can deal with this, square root of positive 6 divided by square root of positive 2. Those are both numbers that I can handle. 6 divided by 2, that's just radical 3. And this little guy in between, right here, square root of negative 1, he gets to be part of the action too, and that is I, and he's going to go with the planes. So this is just 3I radical 3, not square root of negative 3, which is what most people want to do when they see this kind of problem. Okay? If we're multiplying here, we've got 3 radical negative 5 squared, which means times itself. So first, let's adjust. We don't want any negative square roots. We can't deal with those, but we can certainly do this, which is 3I radical 5, and times itself is 3I radical 5. Now, 3I times 3I is 9I squared. I love I squared because I know that's negative 1. Square root of 5 times square root of 5 is 25, square root of 25, which is plain 5. So really this is 9 times negative 1 times 5, which is negative 45. Would you ever have thought that this was negative 45? Okay, same idea here. We've got 6, square root of 1, positive 8. So this is 6I radical 8 squared. 6I times 6I is 36I squared. Radical 8 times radical 8 is radical 64, which is plain 8. This is negative 1, so it's 36 times negative 1, which is negative 36 times 8. Oh, fantastic. On the video, I got to do 36 times 8. How embarrassing. That is 48. 288. I can do it. Okay. Something like this. Cube root of negative 27. This is the trap people fall in because they want to go up. Do I do that? Do I do that? No, because it's not a square root. We know I is the square root of negative 1, not the cube root. The cube root we already know. What times itself is negative 27? Negative 3. Don't have to do anything with imaginary numbers there. In this one, square root of 64 minus 100. Well, that's square root of 36, negative 36. And I know that breaks into negative 1 and positive 36. This is I, that's 6, so we have 6I. Operations here. Okay. Now, here's 4 problems. I want you to pause the video, try these 4 problems. Ready? Pause. And now play to hear my explanation, and hopefully you got these right. Negative 4 minus 5i. This is a negative 1, so let's do this. So now negative 4 and negative 4, those are the real parts. Let's put those together and get negative 8. Here's my imaginary parts, negative 5 and negative 6. Let's put those together and get negative 11i. A plus bi, that works. Finished. Here, oh, I know, I'll just multiply together and get square root of negative 16. That doesn't exist. No, can't do it. I can't deal with this as long as it looks like that. I can't do anything with it. I need to split it into something that I can do something with. Now from here, this is I, and this I can multiply. Positive 2 and positive 8 is positive 16. Hey, I know square root of 16 is 4. So 4i. Please do not multiply those together until we have positive square roots. Negative square root of 50. Again, don't say 50 times 50. We're going to get negative 1 and 50. which is I square roots of 50 times I square roots of 50. I times I is I squared. Radical 50 times radical 50, there's a pair of squares. That makes plane 50. Hey, this is negative 1. Wonderful. So that's just negative 1 times 50, which is negative 50. Finished. And lastly, don't divide and get square root of negative 3. We can't do anything with this. We need to change it. Negative 130. This would be I radical 30 over radical 10. These are both positive now, so now we can divide. Radical 30 divided by radical 10 is radical 3. We have I radical 3. I hope you got all these right. I hope you understand. If I went too fast, it's okay to go back and rewatch. Have a great day.